Hey everyone, I hope you're doing well today. In this video, let's practice graphing some quadratic functions that are written in standard form. In case you forgot, the standard form for quadratic functions is f of x is equal to a times x squared plus b times x plus c. And just a reminder, when the value of a is positive, the parabola is going to open up, and when the value of a is negative, it's going to open down. And if the absolute value of a is greater than 1, then we'll have a vertical stretch, or the parabola will get skinnier. And if the absolute value of a is less than 1, then we'll have a vertical shrink, or the parabola will get wider. The constant of c will always tell us our y-intercept. And when we use a and b together and take the opposite of b over 2a, then we can find the axis of symmetry. In just a moment, we're going to practice graphing a bunch of quadratic functions that are written in standard form using these 5 steps. In step 1, we'll identify our a, b, and c constants. In step 2, we'll talk about what they can help us represent so we know if our graph makes sense. In step 3, we'll use a and b to find our axis of symmetry, or AOS. In step 4, we'll use the AOS to also find the vertex, or the y value for the vertex. And in step 5, we'll make a table of values and then make a graph. In each of the functions that we're going to take a look at, the graphs can either look like this or this if the value of a is positive, or this if the value of a is negative. If you'd like to sit back and relax and just watch how I go over these problems, that's perfectly fine. However, if you want to do them with me, I encourage you to grab some paper, something to write with, and let's do some math together. For this first example, we have the function f of x is equal to 2x squared minus 8x plus 6. Let's go ahead and identify what a, b, and c are. So step 1 is now complete. We know a is equal to positive 2, b is equal to negative 8, and c is equal to positive 6. Because a is equal to positive 2, we know that our parabola is going to have a minimum, or it opens up. And because the absolute value of a is greater than 1, then we have a vertical stretch. It's going to be skinnier than a normal parabola. And because we know the value of c is equal to 6, we know that our y-intercept is going to be located at 0, 6. So there's step 2. Now let's go ahead and find the AOS. To find the AOS, our formula is x equals the opposite of b over 2a. Remember, this is just the equation of an imaginary vertical line that cuts our parabola in half to show us the symmetry as well as it goes through the vertex. Let's go ahead and substitute the value of a and b in to solve for this vertical line. The equation for our vertical line for our axis of symmetry is x is equal to 2. Now that we found the AOS, we finish step 3. So for all parabolas, the vertex is located on the AOS, so the x value is going to match. So we're going to go ahead and substitute the value we just found out for the AOS in for x to solve for y. Go ahead and follow along with me here. So here we just found out that when x is equal to 2, that our y value is going to equal negative 2. We know that our vertex is going to be located over in quadrant 4 because it has the coordinates with a positive x value, or positive 2, and a negative y value of negative 2. Now that we have the vertex, let's go ahead and make a table and then sketch a graph. Typically, it's a good idea to make a table big enough so that you can put 5 ordered pairs, and we always put our vertex in the middle of it. From there, it's a really good idea to create some values that are the same distance away on both sides of it. So I'm going to go 1 up and 1 down from 2, and then I'm going to go 1 more up and 1 more down as well. Because we knew the c value of 6 from the beginning, we knew the y-intercept was 0, 6, so when x is 0, y is 6. And remember, since parabolas are symmetrical, we can put 6 for the 4 value of x as well. At this point, we just have to find the y value for when x is equal to 1 or 3. It's going to be the same thing either way. I think 1's going to be a little bit easier to deal with, so I'm going to find f of 1. It turns out for this function, when x is equal to 1, y is equal to 0. So let's go ahead and plug that in. And now that we have 5 ordered pairs, let's go ahead and sketch our graph. First, I'm going to start by sketching the AOS. Remember, that's just the equation of this imaginary vertical line that's going to cut our parabola in half. The equation of this line was x equals positive 2. Our vertex was positive 2 comma negative 2, and it's always on the AOS. Then we have 3 comma 0 and 1 comma 0, and they should be across from each other. And finally we have 0 comma 6, which is our y-intercept or our c value, and so then we also have 4 comma 6. Sketching a smooth curve through these 5 points, here's our parabola. And finally, we're also done step 5. For example 2, we have the function f of x is equal to 2x squared plus 6x plus 3. Let's start by identifying a, b, and c. So a is equal to positive 2, b is equal to positive 6, and c is equal to positive 3, so let's talk about what they mean. A is equal to positive 2, so we know that our parabola is going to have a minimum and opens up, and we'll have a vertical stretch, or the parabola will get skinnier. And because c is equal to 3, we know that our y-intercept is located at 0, 3. Now that we got that out of the way, let's go ahead and find the AOS. Here's what we'll get for the AOS when we substitute a equals 2 and b equals 6. Substituting in, we found out that our AOS, or this vertical line, is going to be x equals negative 3 halves. Now that we know the AOS, let's go ahead and substitute it into our function to find the y value for the vertex. So it looks like when we substitute in our negative 3 halves in for x, we also get negative 3 halves out for y. From this, we know that our vertex is located over in quadrant 3 at negative 3 over 2, comma negative 3 over 2. Now that we have the vertex, let's work on a table and then a graph. Just like earlier, let's put our AOS and vertex in the center of this table. And let's pick some nice easy values on both sides of this x value of negative 3 halves. So if we increase by 1.5, we'll end up at 0. And if we decrease by 1.5, we'll end up at negative 3. And if we increase by 1 more above 0, that's 1. And we can decrease 1 less than negative 3 to make negative 4. Make sure you make your life a little bit easier by choosing nice values that are equidistant from the x value for the AOS on both sides. I really wanted to use x equals 0. Because we know the y-intercept is 0, 3, so 0 goes in, 3 comes out, and that also means that negative 3 goes in and positive 3 comes out. This negative 4 and positive 1 are equidistant from the middle, so either one's going to work, and I'm going to choose to use the 1 because it's a positive number. Let's go ahead and find out what f of 1 is equal to. So when x is equal to positive 1, y is equal to 11. Let's go ahead and plug that into our table. Right over here and right over here. Now that we have our 5 points, let's go ahead and sketch a graph. Our x values are pretty small, so I'll just go by 1s along the x-axis. But I'll skip by 2 along the y-axis so we can fit the y value of positive 11. Here's the AOS. Our vertex is negative 3 halves, comma negative 3 halves, so that's going to be right along the AOS, but it's going down 1.5, which is actually going to be about 3/4 of a box here. Because remember, each box is worth 2 along our y-axis. Our y-intercept is going to be 0, 3. That's going to be 1.5 boxes up since each of them are worth 2. And it's going to be the same distance away over here on the left side of the AOS. Then we have the point 1, 11, which is going to be 1 to the right and 5.5 boxes up. And we have our other point of negative 4, 11, which is going to be the same distance away on the left side of the AOS. Drawing a smooth curve through these 5 points, there's the graph of our quadratic function. That wraps up step 5. For these next few examples, I really encourage you to pause the video to try them on your own and then unpause to see how you did. For number 3, we have f of x is equal to 3/4 x squared minus 5. And here you have the sketch of the parabola of the given function. Notice how in this function, b was equal to 0. Whenever that's the case, the axis of symmetry will always be x equals 0. Here's a fourth example. We have f of x is equal to 3x squared plus 6x plus 4. Once again, feel free to pause the video to try it on your own, otherwise I'm just going to go through the problem. And there you have the graph of this quadratic function. Hopefully at this point, you feel a little bit more confident with graphing quadratic functions when they're written in standard form. If you found this video helpful, you can let me know by tapping that like button and even consider subscribing. As always, keep up the great work, and I'll see you in the next one.